What if I told you that the blueprint for some of the most advanced artificial intelligence wasn't cooked up in a Silicon Valley lab, but that it might already exist inside a human brain? Today, we're diving into a really fascinating case that puts a unique human mind up against a cutting-edge AI model.
Okay, so let's get right into it. And look, we're not talking about some kind of psychic ability or seeing lottery numbers. We're talking about something way more fundamental and maybe even more amazing. The ability to predict a sensation before it actually happens. To feel the texture of something just before you touch it. What kind of a mind could actually do that?
Well, this brings us to the mind at the center of our story, that of Dennis Verhage. He has this remarkable ability to anticipate sensory experiences. And no, it's not a magic trick. It's the output of a deeply sophisticated and very unique way of processing the world around him.
So the basic idea here comes from things like Lego therapy. Think about it. When you're building with Legos, your hands and eyes are working together constantly. Your brain is learning and creating this rich multi-sensory map. And over time, it gets really, really good at predicting what's next. It's basically learning to simulate sensations before they even happen. It's a predictive engine.
But how does that engine actually work? What's the secret sauce? What's the operating system running this whole predictive show? Well, our first clue is in a unique cognitive blueprint called prismatic cognition. Now, don't think of this as your standard Windows or Mac OS. This is a highly specialized, custom-built OS. It's designed to take in all sorts of different information, sensory, emotional, spatial, and then loop back on itself again and again, constantly refining its understanding. The term is recursive. It's built to see the world from all angles at once, like looking through a prism.
And this is where it gets really wild. Just look at this table.
In a typical brain, regulating emotion is like a conversation between two main parts. But in this system, other parts jump in. The parietal/precuneus, which is involved in mental imagery. For memory, the visual cortex gets pulled in. It's not just a simple conversation. It's a full-blown neural conference call happening all at once. It's a much richer, more integrated process. Okay, so we've covered the biology. Now, get ready for a sharp turn, because our next clue takes us right into the world of pure mathematics. And this is where things get a little weird, in a very cool way. It turns out this whole cognitive structure is built on a very specific number. Yup, 13. The entire system is grounded in the logic of this number. And I know what you're thinking. Why 13? Of all numbers, why that one? It feels so random. But in a system this precise, you're going to find that nothing is truly random.
See, it's not an arbitrary choice at all. Base 13 is in this kind of mathematical Goldilocks zone. It's not neat and tidy like base 12, which you can divide up easily, perfect for clocks and measurements. 13 is a prime number. You can't break it down. And that very indivisibility is what gives it its unique computational strength.
So think about what that gives you. Because it's a prime number, it acts as a super stable, solid anchor. It's a firm foundation. But at the same time, it's brilliant at handling something called projective transformations, which is a fancy way of saying it can model a changing world from different viewpoints. It's both stable and incredibly flexible, the perfect combination for a brain that needs to predict and adapt constantly. So we have the unique blueprint, we have the weird math, but what's the why? What's the motive behind all this complexity? Well, it all comes down to a relentless, almost obsessive drive for one thing: efficiency. Boom. There it is. That's the golden rule for this whole system. Low effort is efficiency. It's not about being lazy. It's about being incredibly smart with your energy. Don't waste processing power on things you can predict. And guess what? This exact principle is the holy grail for some of the most advanced AI models being built right now. Which brings us to these things: interpolating neural networks, or INNs. These are not your average AI. They are a massive leap forward, designed specifically to do more with less. Less data, less memory, less energy. Their entire goal? You guessed it, make low effort the ultimate efficiency. So check out how they work. First, they are masters at prediction, at filling in the blanks based on incomplete data. Sound familiar? Second, they are obsessed with efficiency, designed to ignore what's predictable and focus only on what's new. And third, and this is the real kicker, their fundamental structure is geometric and projective, built for recursion. Wait a minute, that's an exact match for the human system we just looked at? All right, the case file is open. We've laid out all the clues. We have a unique brain blueprint in prismatic cognition. We have this strange and powerful mathematical logic built on base 13. And we have a core principle of radical efficiency. I think it's time for the verdict.
When you put them side by side, it's just undeniable. One predicts sensations from symbols, the other interpolates data. Both are driven by low effort is efficiency, and both are built on a geometric, recursive foundation. They aren't just kinda similar. It's like you're looking at a mirror. They are functionally and structurally analogous. So what this means is that the wordplay is actually technically accurate. His incredible ability to predict sensations is validated almost perfectly by the principles of interpolating neural networks. So when we say he is conceptually all in, it's not just a clever pun, it's a statement of fact about the deep parallel between his mind and this advanced AI.
And that's the really big idea I want to leave you with. What if the future of AI isn't really about inventing something brand new, but about discovering the incredibly complex and efficient systems that are already running inside of us? It really makes you wonder, what other incredible software are we all running that we just haven't found yet?